Hello student, how are you? I hope you all are fine. So student, subscribe my YouTube channel so you can't miss out the upcoming content. Today I am solving here one of the complex problem that is also controversial that has been asked in 2023 IIT Advanced Examination. This problem is regarding wave optics. So in this problem, a monochromatic light wave is incident normally on a glass slab. This is a glass slab, and a monochromatic light incident normally on a glass slab. The refractive index of the glass slab is vary from N1 to N2. N2 is greater than N1. This refractive index is transverse variation in refractive index. This is linearly variable from N1 to N2, and their light wave emerging out the slab, and thereafter the light wave emerges from this slab, and we have to find it will deflect by an angle this, it will deflect by angle this. So we have to find here the deflection of the wave, emerging wave. We have to find here the deflection of emerging wave, and the deflection angle depends on the difference of radiative index and not on individual values of N1 and N2. We have to here in this scenario, we know when a monochromatic light normally incident, the propagation of light is here, so the wave front would be perpendicular. The planar wave front would be here and wave front would be perpendicular here. So in this question, the this is the d height. So we can say here, if we take this distance y from here to here, suppose this is a n1 here, so we here to here we take the distance y. So we write here the refractive index of y would be n1 plus n2 minus n1 into y by h. This is a refractive index gradient, and the refractive index at particular point y at that point would be written as. So here in this problem we have not given the about the thickness of d. The thickness of d is small or large, not given in question. So we first assume the thickness is large, and the refractive index N2 is very large than N1. So in this scenario, we suppose this is a thickness D, and this light ray, this is monochromatic light incident in such a way. So on incident, we assume here the layers. This is the layer of the material, and normal would be perpendicular to this. When this light wave is enter, that this is normal, and this is normal. So we see here this light ray, and this is the normal here. So we see here, suppose this is a, so we take normal here and take normal here. So this would be ray would be deviated. So this is the direction of the ray inside the slab. So we observe here a lateral shifting of emergent ray. This is suppose emergent ray, this is incident ray, this is emergent ray. So we see here the lateral shifting of emergent ray. This is because when the when in medium here to here, this is the region of N2 refractive index, this is region of N1, this region having the N1 refractive index, and N2 refractive index is greater than N1, and the wave front at that particular point, here the we know the refractive index N2 is greater than N1, so optical distance T optical would be optical path that traveled by the ray. Suppose this is A ray, this is B ray, and optical path would be Cy N2 into T. T is the time period. So optical path for this would be, for suppose this ray, this ray, this ray. So optical path for this ray would be, this is deviation. So this ray would be this type, and this ray would be this type, and this ray would be this type, and this ray would be this type. So on drawing the tangent, we see here, this is the initial position of the wave front. This is initial position of the wave front, and this wave front inside the material, this is slab, would be tilted here. So this is angle suppose theta. This is the scenario inside the glass slab, and we suppose this is the situation. If we take, this is very large income, this is very having very value, large value, thickness is large, and then we see the deviation of the um, wave front would be inside the glass slab, and when we find the deflection, so this deflection would be differ from this scenario. So here we consider the thickness is small. This slab is having small thickness here. So when this, suppose this is A ray and this is monochromatic ray B, and when this ray traversing from here to here, so we suppose the lateral displacement is very much, because of this thickness is very less, so the ray passes through like this. So when this ray emerges from this point, so here when we consider the distance of the thickness of the slab is very low, then no deviation would be inside, that would be assumed, that can be assumed. So here this is a planar wave front, and after emerging wave, that emerging wave would be deflected like this, and here we see at that point and that point. At that point, in this scenario, we have given the refractive index, this is N2 here and this is N1 here, and N2 is greater than N1. So the velocity of light, that we consider Va, and that would be Vb. So we write here velocity at for this light ray would be Cy and N2, and this light wave would be C by N1. So we know the refractive index is N1 is low in comparison to N2. So speed of light is more here. So this from wavefront from here to here take least time in comparison to here to here. So this, so we suppose, here, you suppose here this time reaching from here to here. Suppose this is C and this is D and this is E. So this wavefront, this path. So path, what would be the path? Path of AC, path of BC, path of BC, BE. That would be, this is the path of AC. So path of AC, plus we can write here this is the path difference here. So this would be, suppose x, this is the path difference here. So we write here path difference of BC BE, this is BE. So we write here path difference from BE and path difference from BE. So this is path of BE BD plus path DE. So this would be path of AC. So path of BD would be, this refractive index is N1 here and we write here N1 into D. This would be the path difference. And for path DE, this is X. Suppose this is X. We have to calculate here the extra path difference. And this would be N2 into D. So X would be N2 minus N1 into D. This is the path difference because of the when this wavefront travels from here to here, this wavefront having the least velocity in comparison to this. So this reaching here, wavefront reaching here, this type of wavefront spherical, and this is at here. So and at this ray, we suppose this is also a ray. So this wavefront is here, and for this ray, this wavefront is here, and making a tangent here, this type of wavefront here. So this is the tangent on the wavefronts. This wavefront having large radius, this having slow less radius, this having less, this having zero radius here. So we see in this scenario, we see this is the reflected ray, and this would be the wavefront here. So this angle is theta. This is the distance of x distance here, and this distance is given in question h. So this is perpendicular. We know the wavefront and the ray would be perpendicular to each other. This is wavefront, tangent of the wavefront. This type of wavefront is propagating here. So tangent this wavefront from here to here, this tilted from theta. So sin theta would be, this is perpendicular. So what would be sin theta? This would be x upon h. So this would be N2 minus N1 into D by H. This would be sin theta. So if we take the angle is small we take, so we can write here tan theta would be N2 minus N1 into d by h. So theta would be tan inverse N2 minus N1 into d by h. So this option seems to be assumed to be correct. If we consider the theta is small and N2 is, the difference of N2 is not more, very much more than N1. So when we consider the theta is small, then we assume this is the this is the emerging wave deflection. So the deflection we find here, if we assume this theta is small and the thickness is small, so the very important point is here the small thickness. This is valid only when the thickness is small. When this thickness is large, then the here the we see the on normal incident of incident ray inside the material, the rays traversing perpendicular to the plane, but actually when the thickness is large, then the wave front would be deviated here and the rays would be deflected inside the region. So the deflection occurs inside the slab. So so deflection would be differ from this option. So we consider this option assumed to be correct, and this option is incorrect, it will not deflect, and first option is also incorrect, and the final option, the deflection angle depends only N2 and N1, this is correct. The deflection angle is dependent N2 and minus N1 and not individual value of the N1 and N2, so this option is also correct. So here I discuss here one optics problem, and I hope by the concept that I discussed here would we increase your mental endurance, and thanks for watching this video, and take care.